Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The Hoffman rearrangement of Br converts a primary amide, Rcon, to a primary amine, RNH, with loss of CoO and retention of configuration at the migrating carbon, intramolecular migration. Inversion at the carbon bearing the amide group is not occurring, rather the carbon migrates with retention to the nitrene isocyanate nitrogen. The key stereochemical feature is that the alkyl group migrates with retention of configuration at the carbon that migrates. Moving on to the next step. Compound 1 is a cyclohexane ring bearing a CH3 group and a COM2 group at the same carbon, C1, with CH3 on wedge, coming forward. Compound 2 is the same framework but with an ethyl, C2H5, group on wedge and a 15N labeled amide. Moving on to the next step. The amide nitrogen is brominated, then base removes H to give N-bromomide anion, which rearranges via intramolecular migration of the C1 carbon, with its substituents, to nitrogen with retention of configuration at C1, the migrating group, forming an isocyanate intermediate, which hydrolyzes to give the amine. The nitrogen ends up where the carbonyl carbon was, and the configuration at C1 is retained. And for the final step. In compound 1, if CH3 is on a wedge at C1, the amine, NH2, produced will be on a wedge, same phase, at C1 with CH3 also on wedge. Wait, more precisely, after Hoffman rearrangement, the C1 carbon that bore COM2 and CH3 now bears NH2 and CH3. The migration proceeds with retention at the carbon, so the relative configuration of substituents at C1 is retained. The NH2 appears on the same phase as CH3, both wedge, in the product for compound 1 and similarly 15 NH2 on same phase as it for compound 2. But looking at the answer choices, option B shows NH2 on wedge and CH3 on dash, trans relationship on the ring for compound 1 and 15 NH2 on wedge with it on dash for compound 2. These represent the 1,3 desubstituted cyclohexane products where both groups are trans, 1 wedge, 1 dash, consistent with retention of configuration during intramolecular migration in a cyclic system where the amide and methyl are trans to each other on the ring. The starting amide has the COM2 and CH3 at C1 of a methylcyclohexane. They are on the same carbon, quaternary, but the structures shown in the question appear to be 1-methyl-3-amide, cyclohexane or similar. Looking more carefully, the starting materials show the amide and the methyl-ethyl on different carbons of the ring with a specific relative configuration. With off-Br and intramolecular migration, the Hoffman product places NH to where COM2 was, with retention, giving a trans 1-amino, 3-methylcyclohexane, NH2 on wedge, CH3 on dash, for compound 1 and trans 1,15 NH2, 3-ethylcyclohexane, 15 NH2 on wedge, et on dash, for compound 2. This matches option B. A shows CI's products, both substituents on same phase, both wedge or both dash, wrong stereochemistry for Hoffman with retention. C and D either swap the 15N label placement or show wrong facial selectivity. Therefore, the correct answer is B. Therefore, the correct answer is option B.